Alright, we should be live. Let me check this. Alright, we should be live. This. Okay, I think we're good. Let me yeah, I think we're good. Alright. Awesome. Let's see what this looks like on the stream. How easy it is to see the scripts. Let me just go ahead and open these up. Thank you guys for tuning in here. Oh, let me get my display camera going. Let me do that too. Alright, there we are. Let me probably move this slightly upward. Alright, there we go. That's good. Okay, and let me see what this text looks like on the stream, if that's okay to see for you guys. Probably move this. There we go. That's good. Okay, and let me see what this text looks like on the stream, if that's okay to see for you guys. Okay, that should be good. Alright, awesome. Get started. So okay, okay, cool. All right, so where we left off in the last, I guess, stream, created everything. Now we're gonna go ahead and work on the input static methods. Now, like I said, this is gonna be deriving from what I used in the past. So let me just take a look at that. Yeah, it's it looks the same. I have to change the name here real quick to day 2. Okay. So to get input, we're gonna create a new class Unreal input. And this guy is going to have a private static dictionary of a class. We have to create this in a second, so I might as well put this in a Unreal object, and then a class we're going to make called an object input data. So let me make that class real quick. Private I guess class object inputs data. It's gonna hold data per player, so public Unreal object parent public I inputs action collection. This is from that input data input instance public dictionary, and this is going to be actions while we're held. And it's going to be something we're going to create here in a second. So I'll make one more class up here. Inputs. This could be private. No one's going to see it. Inputs. Performed. Handler. I'll just do that for now. And I guess we can call this our dictionary. It's a new dictionary of this. Okay, so I guess this can technically also be private. What's going to be happening is you're going to be able to pass in data to this object data, and you're going to be holding while held actions. So in Unity, there's, if we go to right click, create input actions, just make one real quick, default mapping. You can see we can create bindings, and if I click here and type something and click on it, I can do specific bindings like a space or whatnot. So what we can do is have a public object input data, which is going to be a Unreal object called uObject, and in here we're going to say parent equals uObject controls, and we're going to make this as a template item, so validates inputs controls, where controls derives from I input action collection of a new type. What this means is we can now say if our input instance, which is this guy up here, if it is null, say input instance equals a new controls, and then what we can do is say while held actions equals a new dictionary of this type. So let's go ahead and initialize these. Then we're simply going to return casted to whatever control we want, and we're going to say our input instance. There's going to be a few methods we're going to have to make. So public get inputs mapping context public, oh shoot, what the hell, public Sorry, I'm just a bit exhausted. Get. Actually, we can just call it create input. We have a public boolean for enabling the inputs, and then on this, we're gonna have a. I don't know why I keep spacing that. Public boolean disabling input. So that, right, these are gonna be when we're going to be enabling and disabling that input there. We're gonna have two methods. One's gonna be for our public void subscribe to events, and then public void unsubscribe to events. Okay. So this one, we're gonna say where controls is this, and then on here we're gonna say var controls equals validate inputs of controls, and then we're gonna return our controls. Here, when we create our inputs, we could say get mapping index, but just because if I want to add stuff in here later, we could do that. So again, we're gonna have to say where controls derives from. Enabling inputs, we're gonna say if our input instance is null, we're gonna return false. So whether or not we can enable or disable that specific input, and then have input instance dot enable. Then obviously we did that successfully. Same thing here. So I'll actually just copy these, and this will be disable. Now, subscribing to an event is going to take in a new public type. So we'll say find types. So we're gonna have a public enum called Unreal Input Actions, action type. So we can have started, pressed, and then the other one is canceled. There's only one L in there. Canceled. Now for these, that's great. So this is when you right away press it, when you finish the action of it. So whether or not like you press and then you want to wait a couple like milliseconds or 0.2 seconds or something for that input to be validated, and this is obviously when you let go. Now one other input though we want before the state is to be having held, and this is when we're holding the input. This is something that's being added to onto Unreal input that we're going to be adding ourselves. So in our subscribe input action to events, we're going to say our input action. We're going to pass in also the type of input we want. Unreal input action type, and an action. We're going to pass in the input action, callback context, which is from Unity's new input system, and then it's going to be the event to call. Okay. So first of all, we're going to want to switch the type, and we're going to check a few cases. One is the started case. Our next case is the pressed case, dot held case, and then lastly our case dot canceled. So started is relatively straightforward. We're gonna say our action dot started plus equals the event to call. Same thing for pressed, action dot started plus equals event to call. Our held action is where it gets a little bit iffy. Here we need to do a few things. One is taking our array, our dictionary, and adding to it. So what we can do is say our wild held action of an action equals a new input action handler. Input perform handler, and on this we're gonna pass in the event to call as well as our parents. So let's go ahead and make that class. This one's relatively straightforward. We're going to have a coroutine called the current co, a public action of a input action callback context. So this can be on performing, on performed, and then a public action input action callback context on canceled. And then we're going to pass in some parameters to this constructor here. So one, you might have guessed what we were already doing was having that input action callback context action to call, and then a Unreal object called I'll just call it uObject Unreal. So what we're gonna do is we're gonna say on performed plus equals. We're gonna make a plus equals our context, and we're going to say current co equals uObject dot start coroutine, because it is a mono behavior, while held, and we're about to make this here in a second, action to call context. Okay, and then on canceled, same thing, a context, and then we'll say in here, if our current co is not null, uObject dot stop coroutine current co. Okay, so to define this this enumerator, we're going to go ahead and I'm going to add wild held, passing in an action of input action dot callback context called event to call input action context. And here, while true, and to call dot invoke context, and then we're going to yield return null. So what this will do is while we're holding the key, we're going to keep invoking it every frame, and this will make sure we're waiting that frame in that loop. So that will work, and that will work. That will be fine. So again, this is not frame rate dependent, and you just multiply whatever value by time delta time after the fact. But yeah, so we'll call it every frame. Now that should be fine. So yeah, back to here, when we're creating it into the dictionary, we're mapping it. We're gonna say our action dot performed plus equals our wild held actions, passing in action as that key, and we're gonna grab the unperformed method, and then action dot canceled plus equals wild held actions of that action dot on cancelled. And I'll return. So what I'm doing is I'm going to map it to a new place in memory. We're gonna make sure on performed. So right when we start, we're gonna do this. And then when we cancel it, we'll go ahead and stop that coroutine. So it works as like a held button. Now on canceled, it's really simple. It's just action dot canceled plus equals event to call. Now unsubscribing is going to be quite similar. I'm going to take in actually everything. So unsubscribe to an event, and here we'll just subtract these. And here we're going to say, change this part up. So if our wild held actions dot contains key of action, we're going to simply return if it does not hold that key. And what we're going to do is, now we don't have to map it memory. So what we're going to do is we're going to remove the bindings from that delegate of the action input from Unity. And then we're going to say our while held actions dot remove, and we're going to go ahead and remove that action. And then for cancel, we'll just remove like normal. And those are all our events that we need to handle in the object data for the Unity Unreal input. Let me check something. Okay, so outside of this class, we can make functions to go ahead and call these. So public static boolean, it will input. And then if our dictionary, oh, damn. Okay, if dictionary dots try get value, I'm gonna try to get the U object, and if it outs the object input data associated input, we're going to say value equals associated input dot enable input. Else we're going to return false, because you don't need brackets here. Oh, and then we're returning value here. Apologies. So if it finds the key, great, and only if that input is valid, then we're going to return true. Else we're going to just by default return false. So those two cases need to be checked. Similarly, same thing for disabling. And we're going to say just call disable input. For our unsubscribe and subscribe, I'm just going to copy this. And then I'm going to copy this. Okay, so yeah, static. So here we're going to say if our dictionary dot try get value, and we're going to need to pass in now an Unreal object called U object. One second. Oh, sorry about that. I'm back. So our associated inputs dot subscribe to an event, passing in. I think our intelligence was doing that for us. Action, type, and there it is. Okay. Similarly, same thing. So instead, we're gonna say unsubscribe. So subscribe, obviously. Alright. So our other thing we want to grab is controllings. So we're gonna want create inputs. Here we're gonna pass in a Unreal object called uObject, and again we're gonna be doing this. Return associated inputs dot create input of controls. Else we're gonna return the defaults of controls casted. The other thing we want is mapping. Oh, static. So when mapping, you're going to want to map to a value, right, in memory. So how this works is you can think of this as our memory on the computer, like a page or whatever. And then we're not going to get into frames and stuff. Yeah, just think of like a place in memory. And we might have some places that are open. When we first have things, we want to map to the dictionary to say, hey, our object should go here. And that's going to be type blue. And every time we try to grab it, we're going to grab from this object type and return its contents back to what you're getting. So like on subscribe, on unsubscribe, all these different events. So we're going to want to map it, and we're going to say if our dictionary dot try get value, passing in our uObjects, out our object input data, associated input, and if this is true, we can return associated inputs dot create inputs of controls. Oh, sorry. No. Okay. Actually, let's go about this a different way. I think better would just say dictionary dot try get value. Or actually, let's just simply contains key. And we'll just return false if it already has that key. Otherwise, we'll say an object input data, new input data equals a new object input data, passing in the uObject, and we're going to say our dictionary dot add our uObject and our new input data, and then we can return true. So what this means is that now we've mapped it. So right, we had that. Damn, that looks horrible. So we've mapped in location, right? Let's say this is 0, 1, whatever, those values. Let's say Fred has his own input, the cube or something, Fred the cube, and he's an Unreal object, right? He will go ahead, when you try to access something, you're actually accessing him, and he's going to give you his associated object input data, which will be this class of knowing what things are, what his controls are, and stuff like that. Now, what's great is now we could have another cube, object input data, or something like Sarah or something. And now when you try to grab it, it's going to just know where she is and give you where you need to go. and that's how we're gonna map it. And then the other thing we'd want is a public static boolean called unmap, and we're gonna say an unreal object and a u object. Same thing here. If the dictionary does contain that key, then we're return false. So, oh, and does not contain the key. Else we'll say our dictionary dots remove u object, and then return false. So let's go ahead and unmap everything. Now it's always good to make sure to unsubscribe from delegates, or I guess actions, before unmapping. The reason is because when you try to map again, it's going to create a new object input data, which is fine, but it's not going to know what the instance is. Because if you remember here, when we do create input, it's going to just create a completely new instance of that type, and it just will not know where to make the input. And I think that's everything we need. Oh, it says there's an error. Oh, or not. You know, he's playing games thing. So let's actually make something in essentials and default modules, because this is technically like a scriptable object. And I'll just call this our default input. I guess default Unreal input. Unreal input controls. Just make sure it's not the same name as our class type. Yeah, Unreal input. So when we go in here, we're gonna make one called our default mapping, and we can have a new action that we can define, like space 1 2 3 etc. So for now, let's just say move as one, and this is going to be a pass a value that is a vector2. Just can't really do a button as that. So again, a vector2, and we're going to be doing a up down left right composite. So what this will do is it will take this composite and composite bindings. So when we're doing our up on the keyboard, down on the keyboard, left on the keyboard, and then right on the keyboard. So this will return up and down will be, I believe, X, and then left and right is Y. Yeah, up, down, left, right. Unless this is, I might be wrong, this might be Y. We'll see in a second. So if we save this and then go back out and generate and apply, put that in here. Damn, no one's watching. Okay. So back in Unity, we're going to put it in scripts. That compile. Give me 1 second, guys. Sorry about that. I am back. Was on the good old phone. Let me make sure the audio. Good old phone. Yeah. Okay, cool. So where we left off is, do I have testing? I do not. So I'm gonna make a new folder for testing, and I'm gonna put scenes in here. Delete scenes. So I'm gonna create a new actor, or I guess pawn, we call it test pawn. Okay. And this is gonna be, now we can say using Mythix dot Unreal integration here, pawn. So on protected override, begin play, we're gonna go ahead and start mapping things. So we just made an input called Unreal Input Controls. So we're gonna say subscribe. Actually, yeah, we'll do that in a second. Let's actually do a button type too. I will say like space bar. And here this will be space, and then save. Now we're going to recompile. And I'll show you guys here how that works. So what we can do is say our Unreal input dot, and then we need to map. We're going to say this. So this will go ahead and start mapping it. Now the other thing I want to do is we'll go ahead and say Unreal inputs dot create input, and we're going to be creating it of that name. What's going on here? Unreal I guess it's some reason showing twice. We'll fix that here in a second. So let me see what's the dealio with that. Oh, I see. Okay, so we'll leave them together then. I wanted to keep the scripts together, but I don't want to update the path just in case we move them out of the path. It might do that. So what was going on is, if you see here, there's a path you can give, and one is Unreal Input Controls. Oh, we are gonna do a namespace. Let's do Mythic.Unreal integration. But one here you can see we can give a path. So we can do that, or do a C# class name. So we're just gonna leave everything there. Should fix that. And actually now it's in the namespace there, which is kind of nice. Okay, so back in our test pawn, we can now do Unreal input dot create input this, and then here we can pass in a few things. So we can do, not really passing in, but declaring the template type, So we're going to create an input of a Unreal input controls. I just realized that that's called integration. Damn. Integration. Okay, that should fix that. Okay, there we go. So now we can do this, and then we can say Unreal input dot subscribe to an event, and here we can subscribe. Now what's nice is we can grab a mapping from this equal to this. Alternatively, you can also just say get mapping context from Unreal input dot get mapping context. That's another thing you can do, but I think this is better. Actually, did I not provide that as a type? Let me see, because we have get mapping input mapping context. I might have not. No, we didn't. Okay, that's fine. We can just do that down here, and then it's gonna pass in a Unreal object and then again I'll say if it does not contain the key, return false. I guess return, yeah, we'll do a boolean, and then else controls mapping. We'll actually do this mapping equals default controls. Else, if we know we did right, well, we're going to go ahead and say our dictionary dot target key. Actually, that would be better. And you know what? We'll just return it. There's gonna be a case that might not be valid, but it's okay. And then again, the object, and then we're going to return associated input dot get mapping context of controls. Else, we're gonna return default controls. And then, so now instead you could say var mapping equals Unreal input dot get mapping controls, mapping context of controls, like this. Now it doesn't know the type, but that's fine. So alternatively, you could do it in here, but we're going to subscribe to an event, and the event we're going to subscribe to, so we're going to pass in this, and we're going to say so like I said, we can say Unreal input get mapping context, but it's better to just say mapping here, so you don't have to do two of those cobbles. Mapping, and then what we called it in that here, we call it default mapping dot spacebar, and we're gonna say on pressed, and on pressed we're gonna go ahead and call a lambda method passing in the context, and we'll say debug.log right now. Pressed. And maybe we'll say our transform dot position plus equals vector3 dots up multiplied by 5. This will go up. We'll go up by 1. It's fine. Now when we unsubscribe, this will not work for a lambda. To unsubscribe, you need to pass in a function. Here doesn't know what the type is, so unfortunately unsubscribe will not work here. Let's go ahead and test this out. Oh, and one last thing to do. Unreal input dots enable input. Just make sure we're enabling. Oh, and this. So now, if we create a prefab, called test pawn, pass this in, and let's just create a 3D cube right now as a test, and then here we'll pass in this guy, and then it should work. So you can see it was created there. If we press space, it goes ahead, says press, and it also goes ahead and updates him by 1. That's correct. Now, let's go ahead and talk about holding. So instead of doing this, we can do something like, let's subscribe to events on held, and here we can say context dot read value as a vector2, and we'll say var direction, and now what we can do is say our transform dot position equals a plus equals a new vector 3. Here we're going to say direction dot, I believe, x, and then we're going to keep it on the z-axis. Let me double check if I click play here. Turn on gizmos. So if we look at the cube, where's the camera? Okay, so we don't want to move him on the z-axis, so I don't want him getting closer. So only the x and the y. So say direction.x and direction.y. Now we are going to want to maybe pass in a speed. So we can now say serialize field private float speed, say like 3f, and now we can multiply by speed. And obviously we're going to want to go ahead and do time.delta time to make sure it is frame rate independent. So it's not dependent by that frame rate. So now, if we look at our test pawn, we have a speed value that we can change. I think he's moving, but is he not moving? Let's see. No. Oh. Spacebar, duh. Move. That's crazy. It's like, why is that not working? Okay, there we go. You can see we can go up, down, left, right, and it is now non-frame rate dependent. Now if I change the speed, so let's say like 1. See, we're getting like high frames. I believe there's a way to cap it. Let's say Unity Engine dot. Let me look that up. So we can say target frame rate. Let's cap us at 30, because right now I'm getting, I think, 60. So, or not, sorry, 60, getting like 400. So now we're getting 30. So, okay, it is not moving by. Let's see now. Okay. Oh, I've lost him. Is it getting faster? I don't know. It feels like it's getting slowly faster. I don't know. Let's see. So right now at 2, 1, 1, 1, 1. Okay, let's see if we put that to like 60 frames per second, or maybe like -1, so we're unlimited again. Okay, let's set it to 60 and see. And we'll set them to 1. Okay, let's see. So from here we can 1, 2, 3, 4, 5. Let's try that again. One, 2, 3, 4, 5. Okay. Let's then do maybe 400. Probably should stay unlimited. One, 2, 3, 4, 5. No, it seems to be the same. If we do 15, so very choppy frame rate, it should still take 5 seconds to get there. Let's see. Yeah, see how it's jittering? 1, 2, 3, 4, 5. Awesome. Yeah, okay, so it is working the same. Oh, we lost him. Interesting. When I do up-down movement, it seems to have fluctuated. For some reason, let me remove this so it's back to unlimited. Let me say dots normalized. Just because that might be throwing some offsets. Yeah, when I do up and down, for some reason it seems to be speeding it up. Let me try one more test. So left, right. 1, 2, 3, 4, 5. Okay, yeah. Do like 15. Am I gonna ask AI? This input, let me see what AI says. This input works, but when I do up or down, it makes the speed faster, even to left. Oh, you know what it's doing? is that it's calling it so what we can do this as well, because the problem I think what was happening is it was every time we were performing it was adding more and more of those. So only if it is null we'll do this. We're gonna say stop coroutine, and then we'll say coroutine equal to null, like so, just in case it does get like resubscribed to an event. And if we do, yeah, now it seems slower, more accurate. Yeah, okay. Yeah, that's correct. So 1, 2, 3, 4, 5. See, when we're pressing up, it was like kind of creating another instance. So that's why it was going crazy there. But yep, now it works. Awesome. So now we have simple movements. And look how easy it is to just call it. So now all I have to say is map the input, create the inputs, and do these things. Now, one thing I do want to address is having our extension methods. So currently, all these guys are non-extension methods, which is fine, but it's really annoying to say this all the time when we could say this dot. So what we're gonna do is just put this in for everything. Now what this also means is that both methods are now valid methods to do. What I mean by that, if I actually go back to close some of these guys, our test pawn, it's still valid. This is still valid, but it's the same thing as now saying dot map like this, because now it's passing it in. And this honestly looks a lot cleaner, right? Because now you don't have to say unreal input dot, but you can still do it this way. So now we can say this dot create input, this dot this, as well as saying this dot enable input. And it's a lot easier to see when you're doing this. The only drawback to this method is if you have methods that have the same name as that's in this class, it's going to be hidden, right? That's just one drawback. But obviously this cleans it up even more, so you don't have to define this inside of it. In fact, yeah. Alright, so there's our input for the day. And yeah, it's honestly not bad. I think this looks fine. So what we can do is yeah, we'll leave it there. Actually, what I'm going to do actually is change this around to our test pawn, just so everything, you know, is there. Okay. Awesome. So now we have this. I'm gonna remove this debug, but yeah. So now back on our pawn, we can now pass in that widget. It should still work. No? Oh, HUD's not a thing, so protected override void. I guess public initialized by game mode. You could have a delay or have an enumerator that constantly checks, but if the HUD is null, but this is fine. So there you go. Alright, I think I'm gonna call it there. Thank you guys for watching this hour-long stream. I know it was really tired, but now there's inputs with our Unreal, class types. Next episode, we'll go ahead and combat having mixers, making our own volume mixer that then takes attributes defined in scripts to do various things. Thank you guys so much for watching. I'll see you guys in the next one.